Conditional probability, part 3. So this is using conditional probabilities to make decisions. Example 5. A jogger wants to burn a certain number of calories during her workout. She maps out 3 possible jogging routes. Before each workout, she randomly selects a route. Afterwards, she uses a fitness tracker to determine whether she reaches her goal. So I guess the goal is to see if she burned that number of calories, whatever number she chose. So the table shows her data. Which route should she use from now on? All right, so this has route A, B, and C. And all of these, she reaches her goals. And these, she does not reach her goal. So I think the best plan of action is the first thing we need to do is to make a table. And let's look at our joint and marginal relative frequencies. So I'm going to pause the video and I'm going to create a table. Hopefully you will do the same. This is something we've learned in previous lessons, but we're going to continue to use these tables to help us with determining what to do with our data. All right, so if you remember, the joint and marginal relative frequencies is the ratio of the part out of the whole amount. So the first thing we need to do is quickly look and see how many times this jogger has recorded whether she's met her goal or not. So each of these would be 5. So there's 5, 10, 15, 20, 25, 30, 35, 40, and then 41, 42, 43, 44, 45, 49, 50. So it looks like she's tracked her running route 50 times. So the first one's going to be 10, 11 out of 50, and that's what we're going to put right here. 11 out of 50, whatever that decimal fraction is going to be, that's what's going to go there. So I'm going to fill in the table. You should pause the video and do the same thing. All right, so check your table, make sure your numbers are the same as mine. Again, we just went through and used the little tick marks here in this table to create this table here. So this is going to make it quick and easy to find our answer. So it says, which route should she use from now on? So we want to know when she reaches her goal from route A, when does she reach her goal given route B, and when does she reach her goal given route C? And then if we have all of these numbers, then we can determine which route is her greatest success for reaching her goal. And that probably will be the route that maybe she uses more often. It says that she always uses, I don't know that she will always use the same route because sometimes you get bored and you want a different route. But anyways, it says which route should she use if she wants to reach her goal. So this is just based on statistical data. So let's get started. So to reach her goal, given route A, so we're going to use the formula. So we want to know the probability of route A and reaches her goal. So the probability of route A and she reaches her goal is 0.22. So let's put 0.22. And then that's going to be over the probability of route A. So that's when she reaches or doesn't reach her goal, but all the times that she uses route A would be 0.34. So that's going to be over 0.34. And again, we can change that to 22 over 34 if you want, reduce that, but you can also type that in your calculator and find the answer. So let's go ahead and do these before we use the calculator, and then we'll get all the calculations at one time. All right, so the next one is reaches the goal given route B. So reaches the goal and she's using route B. So if you come back to the table, she reaches her goal and is on route B 0.22 times. All right, and then how often does she use route B? 30% of the time, so 0.30. All right, let's go ahead and look at our numbers for route C. So we already know that this column is reaches our goals, and this bottom one now is reaches our goals and route C. So 0.24, And then all the time that she runs on route C is 0.36. All right, so let's see what these equal. So we're going to have 0.22 divided by 0.34. It's going to be about 64.7%. All right, and then the next one would be 0.22 divided by 0.30, and that's going to be about 73.3%. So we can already see route B is better than route A when it comes in terms of reaching her goal. And then the last one, 0.24 divided by 0.36. And that's going to be about 66.7%. All right, so if you look at this using conditional probabilities and you want to compare what is best, if she's wanting to see when she burns the most calories during a workout, this shows that she's reaching her goal the most often. So that means she's burning that many calories the most often when she runs route B, because 73.3% tells us that 73.3% of the time when she's running route B, she reaches her goal of whatever her calorie burn is. All right, that's all for conditional probability. If you have any questions, let me know.